Hello, my name is John Cleveland representing Power Up Lubricants. What I'm going to be demonstrating for you today is the superior lubricating qualities of Power Up. We're going to be demonstrating different motor oils. We're going to demonstrate Slick 50, and we're going to show you the comparison under heat, pressure, and contamination, how our products work. And what we're going to be demonstrating it with is what we call a modified version of the OK Timken load test. When I say modified, is this test machine was actually developed for testing the film strength of different greases. We've added an oil cup here to where we can actually create a bath where we can put a film of oil on this Timken race, and what we've got loaded in this holder here is a Timken roller bearing. Now this Timken roller bearing has got a similar hardness of a wheel bearing or any bearing assembly inside of a piece of equipment. So it's case hardened to about 58 C on the Rockwell scale. We've got a Timken roller race here that's got a Timken hardness around a 61 or 62. We've got a 3.5 inch holder and a 10 inch fulcrum here, so every time we put a 1 pound weight on this race, we're going to be creating 35 pounds of pressure per square inch. But because we're not running on a square inch, which is, about half the size of a golf ball, we're running on a very, very small pinhead. And the engineers back at our laboratory tell me that every 1 pound weight on a new surface on that bearing is 7,500 pounds, because we're running on just smaller than a pinhead on that roller bearing. Now what I'm going to do before we start this test is I'm going to do what we call a dry run. We're going to see where this bearing is going to fail without any lubricant or oil added whatsoever. So I'm going to load the bearing holder on there. We're going to turn the machine on. We've also equipped this with an amp meter. As we put more and more load on here, we're adding more and more pressure against this electric motor, which is going to cause that needle to move up. Okay? And so we can also see how well the lubricants that we're going to test today save energy. I'm going to turn the machine on. I'm going to grab some weights. And we've got that thing seized up. Let's give it 4 weights. You see these metals have actually welded together. That's how hot that bearing got. And I'm going to have to break that with my thumb there. And I'm going to show you the wear scar. Okay. Now what we're going to do is turn that bearing to a new spot. Okay, the second step in our demonstration is going to be a run with oil. We've got this cup that we're going to place on here. And we're going to select Mobile 1, which is a synthetic oil, probably the most popular synthetic oil on the market. We'll turn the machine on. And now we got enough oil where you can see that there's a good bead of oil running on top of the race. We're going to turn our bearing to a new spot, which we've done. Now, anything over 4 weights, we're going to contribute to the strength of the Mobile 1. Six weights. Also, I want you to notice where we peak out at on the amp meter. Now let's look at the wear scar. As you'll note, the wear scar is about 20%, 25% less than the scar on the dry run. Now what we're going to do in step 3 is add a popular additive. One of the most popular additives on the market is Slick 50. I believe the recommended ratio is 1 quart to every 5 or 6 quarts, but I'm going to put in 50% just to give Slick 50 the benefit of the doubt. We're going to fill that thing up and put about 50-50, 50% Mobile 1, and we got 50% Slick 50 in there right now. Now we're going to take these 6 weights off. Any improvement over 6 weights, we're going to attribute to the Slick 50. Let's turn our bearing again to a new spot. We've got a clear hanger. Grab us some weight. Seven. Slick 50 actually added 1 weight extra over Mobile 1. Also, let's take a look at where our amp meter is peaking out once we seized up. Okay, that concludes our test with the additive. Okay, now we're going to do our run with power up. I'm going to discard the Mobile 1 and the Slick 50, and we're just going to use a good grade oil put out by a reputable manufacturer. I'm selecting Havoline 10W40. And we're going to add a little bit of Power Up. Now, Power Up is a 100% petroleum-based oil fortifier that combines the finest components put together in an additive package that modern technology can provide. Let's add some Power Up in and see what happens. The amp meter is running at just over 5 amps. Okay? Okay, we're going to put the bearing back on. I want you to listen to the difference. What's happened there is you heard a little metal-metal contact, but it's smoothed right out. The boundary lubrication in Power Up lubricants actually works under severe loads and severe pressures. We're actually running under what we call hydrodynamic lubrication, where those two metal surfaces are hydroplaning across a thin film of oil. Now, as we continue to add more and more weight, once we start coming into contact with metal, we call that boundary lubrication. I also want you to get a tight close-up on the amp meter and notice that at 7 weights, the needle hasn't moved 1 bit. Okay, now what I'm going to do is continue to add more weight. Now we've got over 14 weights on here, exactly 15 weights to be exact, which is twice the amount of pressure that we had on when we were running with the Mobile 1 and the Slick 50. Also want you to take another tight close-up on the amp meter and notice that even though we've doubled the load, we're still pulling the same energy out of this electric motor. Power Up, once Power Up is added to your oil, when your engine is loaded, it doesn't know the difference between light load and heavy load as far as how much energy is being burned. We're lubricating that race and that bearing so well that it's taking the same amount of energy out of this electric motor to turn the bearings it did when it had 4 or 5 weights on here. Once we've exceeded 10 weights, we've started to enter what we call the boundary lubrication regime, is where those metals and the oil film between those moving metals is less than 3 microns. And it is so tight a tolerance that only the best lubrication that modern technology can provide, which is provided in our product Power Up, will keep those moving metals separate and quiet without the metal shearing and scoring. So, number 1, we're dramatically reducing wear, and number 2, we're dramatically increasing efficiency. Let's add a few more weights on. Now we have a total of 18 weights on. and we're still running at the same amount of amps. We've got almost 3 times the load, and we're still running smooth with no apparent metal-to-metal contact. Now what I'm going to do is I'm going to actually remove the oil supply, and we're going to show you how Power Up handles heat. I've actually dumped all the oil out, and you can start to see that our bearing is starting to smoke. And I have a temp gun here, and we're going to take the temperature of this bearing We're running 325 degrees right now, and at 325 conventional oils will start to begin to break down. We've all seen the castor oil commercials back in the 90s where they would show viscosity and thermal breakdown where the engine would actually seize up. We're running in excess of those temperatures right now. In fact, 1 ounce of Power Up to any good grade oil, 1 ounce per quart, will boost the viscosity and thermal breakdown point from 325 degrees to well above 450 degrees. So we can continue to run on this bearing with no oil, with temperatures in excess of 375, 400, 450 degrees. We're now at 350 degrees, and we're still running smooth. All of this with absolutely no engine oil at all in the cup. We've emptied the cup out, and we're just running on residual. The third step, or the third major enemy of motor oil, is contamination. This is a mixture of water and antifreeze. Let's add some water and antifreeze and see what happens. Power Up can handle all but the most concentrated contaminants. We've had engines break seals, flood the engine with water, diesel fuel, and even glycol. Power Up can handle all but the most concentrated acids without breaking that film down. So we have a boundary lubricant, and our other additives are joining together in protecting that race and that bearing from major damage. Now I'm going to take these weights off. And as I do this, the water will stop boiling, because as we take the load off, we're also taking the pressure off, which is causing all the heat. Now that we've allowed that bearing a chance to cool down, we're going to remove the bearing holder, and let's take a look at the wear scar. And you can see that the wear scar is slightly increased in size. We ran probably 10 minutes versus 10 seconds on that bearing surface. And although it has increased slightly in size, it's more or less just polished that rough surface up. With Power Up being able to handle loads at the weight that we were running on here, we were running in excess of 150,000 pounds of pressure per square inch on that bearing. Power Up will handle up to 200,000 pounds of pressure per square inch. Now what we're going to do is we're going to turn this bearing to a new spot. Instead of pouring this contaminated sample out, we have water, antifreeze, and a little bit of Power Up and oil left in the bottom of this cup. We're going to run an apples-to-apples comparison under these severe conditions. And all I'm going to do is turn my bearing to a new spot. We've got the hanger cleaned off. We're going to turn the machine back on. We'll take the 7 weights that we seized up, 6 weights we seized up with Mobile 1, 7 that we took for Slick 50, and I'm going to throw another one on just for good measure. And keep in mind, by rotating that bearing to a new spot, we're running on the size of a pinhead. The surface area that we're running on right now is very, very, very small. We didn't hear any metal-to-metal contact. And I want you to take a look at the wear scar. Just going to wipe it off with a paper towel. And you can see how much we've dramatically reduced this. Now what we're going to do is we're going to drop the oil cup. We're going to pour the water and antifreeze out. And one of the proprietary components in Power Up are the retention agents. Now most metals have a negative charge. Power Up has a positive charge. So what happens is at the time of shutdown or in the areas where you get poor oil flow, Power Up actually magnetically charges and magnetically attracts to the metal surface. So in the time of shutdown, or if you've even got a severe contamination, there's still a good lubricating film protecting that race. Now, the difference between Power Up and other metal treatments is Power Up does not coat or plate the metal. It doesn't change the tolerances of the metal. And all it does is really treat the oil. Power Up doesn't change the engine or transmission. There's no buildup. All it does is treat the oil itself. I'm just going to wipe it off with a paper towel. I'm going to wipe the excess off the bearing. We've got 8 weights on here. I'm just going to put the bearing back on. We'll be right back to where we started. And we've seized that bearing right back up. Now just to show you how strong Power Up is in its concentrated form, I'm just going to place 1 drop here on the machine, and I'm going to take my finger and just cover the bottom of the race with that drop and just lift up on this handle just a little bit to let it get 1 rotation. And that 1 drop of Power Up is lubricating this bearing in that race and keeping those moving metals apart better than an entire cup or crankcase full of Mobile 1 and Slick 50, or any other conventional brand oil that you'll find on the market. Now that 1 drop will take our entire load here without missing a beat. Also, I want you to tidy in again on the amp meter and notice that we're running at a full load of 18 weights, approximately in the excess of 150,000 pounds of pressure, with just the film. This little drop that I had on top of this race is protecting those 2 metal surfaces. This concludes our demonstration of the Power Up NNL 690.